Hello and welcome. Reciprocating cycles analysis involves details of an Otto cycle or diesel cycle or some other kind of closed process cycles. If one is interested only in the overall analysis, then closed steady cycle is the best path to go. But the details of a cycle is actually based on a series of closed processes. So it's important that you go over these two videos before working on reciprocating cycles. So in short, let me go over where are the resources for reciprocating cycles. Chapter 7 in your textbook and in test covers reciprocating cycles. Basically, it's energy, entropy, and exergy analysis of a cycle, such as Otto cycle, diesel cycle, and other cycles such as Atkinson cycles, Miller cycle, two-stroke cycles, etc. So I'll quickly go over a couple of animations to show you what I mean by detailed analysis. In chapter 7, SI engine, this animation shows the working of a spark ignition engine, and the Otto cycle is the model behind it. The TS and PV diagrams are shown here. Similarly, the compression ignition engine is the actual engine, and the model for that is the diesel cycle. It's an ideal cycle, air standard cycle that mimics what happens in a compression ignition engine. Similarly, you will find other cycles like Miller's cycle, two-stroke cycles, Atkinson cycle, etc. In chapter 7 animations. So let me go over where you find the test step for that. So as you can see, you follow the system analysis closed track, closed system, unsteady, but follow the specific path, and that leads you to IC engines and reciprocating cycles. So when you click there, you are faced with the number of material models. Obviously, for Otto cycle, diesel cycle, etc., you're probably going to pick PG or IG model. But suppose you want to analyze a steam engine, which is working on a reciprocating cycle, then you can use the PC model. Anyways, so let's quickly use the PG model, and because I want to keep the video short, I don't want to go over an entire problem. You can always see the detailed solution right here, one of those video solutions. But what I'll do a shortcut. I'll just take the test code from here and regenerate the solution very quickly. It's a standard Otto cycle problem, and I just want to walk you through. I Control C, copy that, and I go to the reciprocating test step page, IO panel, and I paste the code back here. You'll notice the code means it has all the state information, state 1, 2, 3, 4, and the processes, process 1, 2, 3, 4, which constitute the Otto cycle: compression, combustion, closed, and then expansion and blow off. You'll notice that also the user code R equals 10 and Tmax equals 900 are used. These are compression ratios and maximum temperature used. So for example, you will find the user code used in test code. For instance, for state 2, notice the volume is expressed in terms of R, where R is defined, volume 2 is defined as volume 1 divided by R, where R is 10, the volumetric compression ratio. Anyways, clicking the load button reproduces the solution. Very simple. So all the states are now, you can see, all calculated. You can go to the graphics panel and draw a constant volume line through state 1 and state 2. And as you expect, constant volume line should pass through 2 and 3 and 1 and 4, because these are constant volume processes. In the process panel, similarly, if you go, you'll find all the processes have been calculated here because we loaded test code. All the 4 processes are done. And in the cycle panel, all the cycle variables are reported. As soon as the cycle is complete, all the cycle variables are reported here. So I don't want to spend too much time here. To let you know that you can always go to this hands-on examples, and you will find a number of examples right here, video examples as well as test solution. and you can explore how to use these test steps in this page to solve any kind of reciprocating cycles problem.